All right, Gipsters, moving on to daily lesson 34. This time, our goal is a little different. We are going to be graphing real-world inequalities on number lines. So remember, inequalities mean less than, greater than signs, less than or equal to, and greater than or equal to. So let's go ahead and take a look. Page 3 where it says daily lesson 34. So your parents leave you a note on Saturday morning. It says you better have at least 5 chores done by the time I get home. And then there's this other statement that says they leave you a note saying you better have more than 5 chores done when I get home. What I want you to think is, what's the difference between the two notes, and how would you avoid getting in trouble while still doing as little work as possible? I guess what I'm trying to say is, which one of these would you rather have left for you on a Saturday morning? You better have at least 5 chores done, or you better have more than 5 chores done? This is what today's lesson is all about. Well, when we say at least 5 chores, that means they want you to have 5 or more chores done. 5 or more chores done. But here, if you better have more than 5 chores done, that means if you have 5 chores done, you're going to get in trouble. You have to have anything, any number, more than 5. So this one, if you have 5 done, you're okay. So if you got 5, you're okay. You're not in trouble. But on this note, if you have 5 done, if you've got 5, you're probably in trouble. Forever. Just kidding. I don't know what your parents are like. I would be in trouble forever, but maybe you wouldn't be. Okay, so let's think about this actually for our work today. So I'm going to give you a statement, and then we're going to try to write an inequality and then also graph it. Sometimes it's easy to do the graph first. Sometimes it's easy to do the inequality first. Just kind of depends on you are. So it says Caleb has at least $5. So if he has at least $5, that means that's the smallest amount of money he could have. What other numbers of money could he have? If he has at least $5, he might have $10, he might have $12, but the main idea is at least 5 means at the lowest and least. So that means it's going to include every number to the right of 5. He might even have $100 for all we know. All we know is he has at least $5. So here's how we show this. I'm going to do C for Caleb. Whatever money he has, it has to be at least 5. So that means it's 5 or more. So C, Caleb's money, is greater than 5, but it also could include 5. So that's why I color the dot in, just like a test, right? If you want answer A on a test, if you want to include it, well, I made the D one much bigger. If I want answer C, I fill it in. I want to include it. If I want answer A and C, I fill both in, right? The ones you don't want, you don't fill in. So let's try this next one. It says, Tarek has more than $5. So that means he doesn't have 5. He has to have more than 5. So it means I don't want to include 5 in the set. So I leave it open, just like it were an answer on a test. But I want all numbers bigger than 5. And so let's go ahead and see. I'm going to say T must be, it's not greater than or equal to, it's just greater than all by itself. So if you want to include it, color it in. If you don't want to include it, leave it open. All right, let's see if we can try the next ones. And what I would encourage you to do is, I think you guys can figure this out. I would say pause it, see if you can figure these out, see what you can do, because you might not be as bad as you think it is. Okay, so this next one says Vanessa has at most $5. So it means it would include $5. It means at most would mean 5 is the highest number she might have. So that means she might have $5 at most. Doesn't say she has less than that. That means that's the most she might have. So it means it could be any number less than this, but it can't be more than that. So our arrow goes left for how we graph this. So it means V for Vanessa is going to be less than 5, but it also includes 5. So I say V is less than or equal to 5. All right, let's keep going here. It says Li Chen has less than $5. So that means 5 is not included, because that wouldn't be less than 5, right? 5 is not included. Now, if that's the case, I shouldn't fill this in. I'm going to leave it open, and I'm going to say it's anything less than 5, which is always on the left is what less means. So this means L for Li Chen should be less than 5. Doesn't include anything else. It's just less than 5. All right, so we looked at a couple anchors there, though you can always look back to those to help you figure this out. Let's go ahead and try a couple problems on the next page together. So on this next page, page 4, it says Kelly works for a quick oil change. So maybe you can imagine like a Pep Boys or something. It says if customers have to wait longer than 20 minutes for the oil change, the company does not charge for the service. The fastest oil change that Kelly has ever done took 6 minutes. So that would mean here, 6 would be included. She's done one that is 6 minutes long. But we don't want it to go over 20. That makes us think, well, it can be 20, right? So maybe I should write some of the stuff down that I know. So fastest is 6 minutes. We don't want it to be, it can't be bigger than 20 minutes. Can't be bigger than 20 minutes or we'll be in trouble. Then they get it for free. And let's see. It wants to show all the possible times that could happen if you have Kelly changing your oil. And then it wants us to use the variable t for time. So I'm going to say I need to use t for time as my variable when I write my inequality. Okay, so let's try this. So we know it could include 20, but we don't want it to go over. Don't go. Because then free stuff starts happening, and that's not good for a business. So, but it could be anything less than 20, right? But why isn't it going to be less than 6? Because it says she's never done an oil change faster than 6. So it includes all of these between here, okay? So that means t, the time it takes, it has to be less than 20. But there's no way it's going to be smaller than 6. So I'm going to say it's also going to be greater than 6. So our time is not going to be less than 20 or more than 6. So let's think here. Does it also include 6 and 20? Yes, because she's had one that has taken 6 minutes. So I'm going to say t is greater than or equal to 6. And here it does include 20, just can't go over. So I would say it's less than or equal to 20. Now here's the nice thing. You can check and see if this works. Here's how you can do it. You can test your inequality using substitution, and it'll help you decide if your inequality is correct. So all I do is I pick a number for my graph. So here's my inequality. Looks like 10, we said 10 would work, but we said 4 would not. Let's test that and see if that's true. So let's try 10 first. So 6 is less than or equal to 10, which is less than or equal to 20. So is this true? Let's test it one at a time. Is 6 less than or equal to 10? Yes, that's true. Let's test the other one. Is 10 less than or equal to 20? Yes, so we must have it colored correctly. Let's double check with 4 though. 6 is less than or equal to 4, which is less than or equal to 20. Let's go ahead and check and see if it's true. So here, 4 is less than or equal to 4 is less than or equal to 20. That works, but here, 6 is less than or equal to 4. That's not true, so that doesn't work, which, good thing, we didn't color it in. So that's how you can check it and see what you can do. All right, so you've got a couple real-world examples to try on your own after this. Right now, go into stretch 2, write down 2 or 3 or 4 things you know. Then I want you to try to graph it and try to write your inequality on your own. And here's the thing, you might keep watching this video and not try on your own because you think, oh, well, that way I can just watch it and get the answers. But here's the thing, eventually you're gonna get to the problem set on the next page, and this right here is gonna be kind of confusing. It's gonna take you longer to do if you don't try to get an explanation now. So I would say stick with this, try it for a couple minutes, and then move on and try to get to what you need to get to. All right, so I know that he needs to work at least 6 hours to save enough money. But he can't work more than 16 hours. So fewer than 16 hours. And it wants us to use H to work here. So at least 6 hours means he could do 6, but that's the lowest he can do. So I'm going to start shading to the right. And then 16, it has to be fewer than 16. So it can't be 16, so I'm going to leave it open. So I'm going to say anything between there is good though. So I can have H, which is greater than or equal to 6 hours, but it has to be less than 16. I don't say less than or equal to because I don't want it to get to 16. That's not going to work. All right, so now we can test a couple values and see if it works. So I might try 12 to see if I'm right. If 12 works, then this, what we have drawn, works. Whoops, 16. Well, let's check and see. Is 6 less than or equal to 12? Yes. Is 12 less than 16? Yes. So we must have drawn this correctly. All right, so same thing as last time. All you do is go on into your problem set. This time I want you to write some of the inequality words or phrases you see. So for example, this one says, Blaisen is at most 2 meters above sea level. Your inequality words or phrases in this one, for example, would be at most. So I want you to write those down and code them each time you work. Write your inequality and you graph it on here. For your inequality, you can use any variable you want. So if it's Blaisen's, you might use B, or you can use X or whatever letter works for you.